Hi everyone, my name is Ryan. Welcome to Math with RG. In today's lesson, we're going to be learning about interpreting graphs of functions. All right, and study tip for today, as I always say, make sure you read the question twice and then answer it. And then instead of just moving on, read the question again to make sure that you answer what they asked of you. I see sometimes my students, they get excited because they have an answer and then they just take off and they don't even check their work. All right, let's dive into it. Here we go. So we've got this graph here. It says cars sold in the US. The y-axis is in the thousands. We're going from 10,000 up to 120,000. And then the x-axis says years since 1985. Okay. So let's go with the first part. They want to know, is this linear or non-linear? All right, so for linear, what that means is it's a line, right? So it has to have a slope, okay? It also has to be straight. This is a curve, so this is non-linear. We can see that there's no constant slope and that it's completely curving up. Okay, so that's our answer for the first part. Second part, it says, what do the intercepts of the graph mean and where are they about? Okay, so let's look at the intercepts. Now, when they say intercepts, they mean y-intercept or x-intercept, or both. So as you can see here that the curve is not actually touching the y-axis, and it's not actually touching the x-axis. But for the y-axis, we can see that eventually it will hit that. So it looks like it's going to hit it at around 20,000 cars. So what does that mean? So let's say it does hit it right here. Well, that would mean 0, 20. All right, so what does that actually mean? That means, in this case, this is a real world problem, right? When we said the x-axis is years since 1985, if I'm at 0, so 0 years since 1985, then that means I'm at the year 1985, and we sold about 20,000 cars. Okay, so now for the x-axis, are there any x-intercepts? Well, you can see that the curve is not touching the x-axis, and it's not going to touch the x-axis, right? Because it's curving right into that 20,000 on the y-axis, so we won't have any x-intercepts. Okay, so we have a y-intercept, and that's at 0, 20, so it means at the year 1985, 20,000 cars sold. All right, so for this problem, that was the beginning, right? Because they wanted to start at 1985. All right, the next part says symmetry. So it means, is there any symmetry in the graph? Okay, so when we look back at the graph, symmetry or symmetrical, right? What does that mean? Look at my hands. You see how they're symmetrical, right? It's like looking in a mirror, right? So we're looking at if any of the graph is mirrored to another side. So we have to look left to right. When we look left to right, we can see the graph is curving up, but there's no symmetry. There's no mirror action happening. So there's just no symmetry for this problem. That is the answer. No, whoops, symmetry. Okay, so the next part says, where is the function positive, negative, increasing, and decreasing? All right, so it's asking 4 different things here. So let's start with the first one. Where is the function positive? All right, well, what does that actually mean? Well, if we look back at the function, when it says where is the function positive, that literally means where is it above the x-axis, which would make the y positive, right? If we're above the x-axis, that would make the y positive. So I have to look left to right in order to figure that out. So if I start at the left of this graph, right, at that 0, 20, it's already above the x-axis. Then as I continue going to the right side, it's still above the x-axis the entire time. So I would say the entirety of this graph is positive. So for the positive part, right, I would say all. Okay, now they're asking, where's the graph negative? Well, since it's above the x-axis the entire time, then it's not negative anywhere. So we can say never for the negative. All right, so now that's done. All right, now we go back to the graph and they're asking about where is it increasing. Now, this is really important. When they say increasing, they're talking about the y terms going up. So I always look left to right and I see if the graph, if the y terms are going up as I'm going to the right. So I look on the left part, right? The leftmost part is hitting the y-axis basically at that 0, 20. And then when I go to the right, it's increasing the entire time. So where is it increasing? Again, all, right? Or if you want to say from 1985, right? So the 0 year, basically, right? 0 years since 1985. So from 1985, forever, basically, right? Infinity for this graph. Okay, and then they said, where is it decreasing? Well, because it's increasing the entire time, that means it's not decreasing at all. Okay, so never for the decreasing. Okay, so now that's done. All right, so then the next part says, is there an x-coordinate of any relative extrema? Well, first we need to understand what relative extrema means. Relative extrema means the peak of a graph, right? So let's say it's going up, and then it peaks, and then it starts going back down, so that very top point. Or the valley of a graph. So if we're going down and then it curves back up like this. So if you look at this, it's starting on the left-hand side and it's just immediately gradually going to the right as the years go by and going up. So there isn't a peak or a valley. And in fact, this looks like an exponential function. Exponential functions do not have peaks or valley, so there is no x-coordinate for a relative extrema. None. All right, and then the last one says end behavior of the graph. What is the end behavior of the graph? So end behavior means what is the end behavior on the left side and what is the end behavior on the right side? Because as you can see, there's arrows in both directions. So when we say the left side, because this is a real world problem, we're not going to go into the negatives because we're not going to do negative years, right? Because it's saying that at 0, that is 1985, and then years since 1985, so 1986, 1987, and so forth. So we would say, and you always want to preface it by starting with this, the x-axis. So as x is approaching 0, which is year 1985, y is approaching 20,000 cars sold. So as x is approaching 0, or you can say year 1985, then y, or some people call it f of x, right? If we're doing function notation, then they would want you to write f of x, right? So y or f of x is approaching 20,000 cars. All right, so now we look on the right side. So now on the right side, right, as x is approaching, now they didn't tell me how many years this is going to be, right? So we're just saying years since 1985. So right now we would just say that it's going to go on forever. So infinity. So as x is approaching positive infinity, right, on the right side, then the y, or the f of x, is approaching 120,000 plus cars, right? So again, infinity. X is approaching infinity. Y, or f of x, is approaching technically infinity as well, but as you can see, it's going to be doing 120,000 plus cars. So in other words, as the years go by, the cars being sold just continues to increase. All right, we did it. Thank you very much for watching Interpreting Graphs of Functions. I will see you on the next lesson. Great job on finishing today's video. Thank you so much for watching. Please don't forget to like and subscribe, tell your friends and family. And if you want to dive deeper into chapter test work, you can check out my Skool platform, skool.com. The link will be in the bio below. And if you want more information on one-on-one tutoring, you can check out my website, rgtutors.com. Thank you again, and I'll see you on the next video. Bye-bye for now.